Hello guys, welcome to the fun part of calculus. So this is the application of differential calculus. It is where we get to do measurements as well as different part of calculus. So you apply calculus. Trust me, if you're writing junior exam or you're writing your supplementary exam on November, this type of question is going to be there. And you know what's the fun part? All you need to know, you just need to know your formulas. That's it. If you know your formulas on application of calculus, you're actually done with the entire thing. So let's actually stick around and see how I am going to handle this wonderful question with the application of calculus. Guys, as most of you may know, I actually have paid extra classes online that is actually called the exam focus. So if you want to join the exam focus, you're going to text me on these numbers. So let me tell you something about the exam focus. We are not only focusing on the junior exam. We are not only focusing on trial exam. We are as well focusing on the big one, which is the final examination. So if you are writing your supplementary exam in November, or you are in grade 12, or you have a child that's actually doing both, ensure you contact me on this number and I enroll you to the exam focus program. We have daily learning and we do have daily live sessions. As from today, we're gonna be having daily live sessions as well as receiving materials through your emails and the many other ways we will be learning. I am telling you this. We teach mathematics, physical sciences, sometimes life sciences. Learning has never been better. So ensure that you join the exam focus program today. Well, with that being said, guys, let's actually focus on this wonderful question, the application of differential calculus. Well, before we go any further, we are being told that the area of this thing, it is actually 20 meters squared. But what is this thing? If you check, this thing, it has a rectangle. Can you see this rectangle? This is a rectangle. So this is how we do it. We're going to say, okay, what is the area of a rectangle, right? What is the area of a rectangle? So the area of a rectangle, it is going to be length times breadth, right? It is the length times the breadth. What about this? This looks like a circle, but this is a semicircle. On the statement, it's just that I didn't copy the statement from this question paper. This is a semicircle. So we know that the area of a circle, it is going to be pi r squared. But since it is a semicircle, it is half a circle, we divide it by 2, right? Because it is the area of a semicircle, or it is the area of half a circle, we're just going to divide it by 2. Now, we know that the area of this entire thing, we're going to add these two areas, right? Because, oh, by the way, Marvel, why are you talking about areas? Because they're given me that the area is 20, so I just want to know the formulas of area. So the area of this entire thing, the area of this total stage, it's just going to be, okay, let me just say area. It is going to be length times breadth plus this one, 1/2 pi r squared. It is the area of these two. I'm going to add the areas because these two are actually added, right? Now, the first question says, hey, find an expression for the total area in terms of pi. I already have got pi. In terms of r, at least I've got r, and in terms of I. And this is going to be my I. Now I'm going to come and say, okay, what is the value of length or whatever? But let's actually look at this part. This is the radius of the semicircle. And we know that the radius of a circle are actually equal. So if this side is actually r, it also tells me that also this one, it is going to be r. So it means that the total, length of this thing from there to there is just going to be 2r. I'm just going to add this 2. So what I end up having is I know that my area, it is going to be, what is my length? Let me just say my length is 2r. And then what is my base? Let's just say my base is going to be I, because we also know this side is also going to be I. And we also know this side is going to be 2r, right? So this side is 2r, this side is 2r, this side is I, this side is I. So the base is also going to be I, plus 1 over 2 pi r squared. So this becomes the expression they wanted me to show. I've actually showed the area of this entire expression in terms of pi, in terms of radius, as well as in terms of L. It's simple, guys. It is simple math. Now, the next question actually say, show that the length, this length, it is given by this expression. So do not panic. Do not panic. So they want us to show that the length of this expression is given by this expression. So how do I do that? How do I show that the length of this expression is given by this? Well, this is what you need to do. I'm going to say, okay, I know that the area is actually 20 meters squared. And this is my area, right? So with this area, I'm just going to put 20. I'm just going to, okay, I know that my area is 20. And then I just want to copy the whole thing. So I'm going to say 2RL plus 1 divided by 2 pi r squared. Well, I want to make L subject of the equation, just like what they have done here. So I want to make L subject of the equation. So what do? How can I make L subject of the equation? So it means that I'm just going to, I'm just going to take this and put it to the other side. So I'm going to have 20 minus 1 over 2 pi r squared divided by 2RL. All right? So I'm going to have 20 minus 1 over 2 pi r squared divided by 2RL. Now, what do I want to do? I noticed that on the original expression, pi r squared do not have a half. The pi r square, it doesn't have a half. So what do? I'm just going to take the lowest common factor on this side, on this right side, this side. I'm just going to take the lowest common factor to get rid of, because like on the original expression, we do not have a half. So what do? So to take the lowest common factor, we know this is the same as divided by a 1. You want to multiply these two. You're going to say 1 times 2. You're just going to put it and say 1 times 2. To make everything simple for everyone, I do not want to complicate things. The moment you take the lowest common denominator, you're going to say 1 times 2. It is 1 times 2. And then you say 2 times 20. That's just going to give you 40. And you say 1 times 1 is going to be minus pi r squared. And this is going to equal to 2RL. Now, you want to get rid of these things. You know this is the same as pi divided by, this is the same as divided by 1. So you want to cross multiply this. So you're going to have 40 minus pi r squared. That actually equals to 4RL. So now you want to be left with the L. So you want to divide both sides by 4 pi. So you realize that these two will actually cancel out, and you will be left with L that equals to 40 minus pi r squared divided by 4r. And it is exactly what you are having here. So these are simple questions, simple stuff. But people find them complicated. I don't know what's happening. Now let's look at this. Now the question says that we need to show that the perimeter of P of the figure is going to be given by this expression. What is a perimeter? Perimeter means adding all the side of this figure. We want to add all the side of this figure. If we add all the side of this figure successfully, we're going to get a perimeter. So what is the perimeter of a circle? What is the perimeter of the circle? What is the formula for the perimeter of the circle? So the perimeter of the circle, it is given by 2 pi r. This is the formula for the perimeter of the circle. It is given by 2 pi r. This is a semicircle, right? This is a semicircle. It means we're gonna divide this by 2. And it means that the formula for the perimeter of this circle, it is just going to be pi r. Do you understand it? The perimeter of the bigger circle is 2 pi r. So because it's a semicircle, we want to divide it by 2. So it means that the perimeter of this thing, we're just going to add all sides. So the perimeter of this circle, can you see it? The perimeter of this circle, it is going to be pi r. The perimeter of this side, because we're having this point where it's actually joined in here, is going to be 2r. Plus, we're having I, it's going to be 2i, if you add these two. And you're also going to add this one. So let's see what the perimeter is given by. You realize it is given by 20 divided by r, 2r plus pi r, right? Now, you want to be extremely smart from the next move that you're going to pull here. You realize you're actually having your L. Can you see this L? If you realize that you're actually having your L, you have an equation of L. So it means that where there is L, you're going to substitute this. So it means that my perimeter is going to be pi r plus 2r plus 2. And the value of L is going to be 40 minus pi r squared divided by 4r. And what do I end up having? I end up having pi r, or this is p, plus 2r plus, you are going to have a situation like this here. You're going to have a situation of 2 divided by 4. You're going to have 2 divided by 4. This 2 will divide this 4. This 2 will be divided by this 4. And it is just going to be a half, which will multiply 40 minus pi r squared. So it is going to be pi r plus 2r plus 20 minus 1 over 2 pi r squared. So now you want to add everything that actually have, what is this? You want to add everything that is actually having a common factor in a way. If there's anything that's actually having a common factor, we just want to add them up. Because, oh, this is 40r, right? So this is going to be 1 over 2r. So this is going to be divided by r. So this is just going to be r. There won't be an r squared. Okay, so you want to add everything. So you are having what? You are having pi r and minus 1 over 2r. So this is the same as pi minus 1 over 2 pi, and you end up getting 1 over 2 pi. So p equals to 1 over 2 the pi of r plus 2r plus 20 divided by r. So this becomes the expression which you were looking for. It is 20r, it is 20r, 2r, it is 2r, it is pi divided by 2r, it is pi divided by 2r. So I'm like left with 30 seconds, but on the next video, I will be calculating this value. But to give you a clue, just derive this expression and equate it to 0 and find the value of r.